Welcome back to You Revise, where we talk about everything exams. Question 37A from the 2017 exam reads, in 1971, the seventh manned Apollo mission, which is Apollo 13, was launched and expected to land on the moon. 2 days into the mission, one of the oxygen tanks exploded. The mission was aborted, but in order for the spacecraft to return to Earth safely, many problems needed to be solved. A number of them involved chemistry. The spacecraft consisted of three sections, the service module, the command module, and the third one was the lunar module. The lunar module was designed to hold two astronauts for the short trip between lunar orbit and the moon's surface. On the trip back to Earth, the astronauts were required to spend more time than expected in the lunar module. One of the problems encountered was how to remove the carbon dioxide breathed out by the astronauts from the atmosphere in the spacecraft. This was done by reacting it with lithium hydroxide, which was housed in canisters. Write the equation for the reaction between carbon dioxide and lithium hydroxide to form lithium carbonate and water. That was worth 2 marks. According to the examiner, question 37 was attempted by 4,986 candidates. The mean score was 15.5 out of 24. The examiner goes on to say parts A, B, and C were straightforward questions and answered well generally. Okay. When we are looking at this question here, we are required to write a balanced equation for the reaction between carbon dioxide, lithium hydroxide to form lithium carbonate and water. The fact that we are given the names of reactants and products, it means we are not required to learn the reaction between metal hydroxides and carbon dioxide. So that is not a big issue. I'm not going to go further into the details of that. But if you are required to write an equation, one thing you need to make sure is the equation must be ionic. Any spectator ions must be removed if there are any, and any substances that exist as ions must be written as such. The equation must be fully balanced, which means by fully balanced I mean balancing the atoms, and the charge as well must be balanced within that equation. And also all the states must be clearly written within in the balanced equation. Okay, so here are the steps that I've just outlined. I know I said a lot, so I'm writing them down. So all species that exist as ions must be written as ions. All species or spectator ions that must not be a part of the final equation must be removed, and the equation must be balanced. And the fourth one, all the states must be included. Okay, so how do you write an ionic equation? There are steps you are supposed to follow. So step number one, I always advise my students, don't go straight from the word equation to ionic. You write your molecular equation first. Use the information in the question to deduce or determine the states of your reactants, because there will be enough information in the question to determine that the states of your reactants. That's number one. Number two, what you need to do then is to use the solubility tables to determine the states of your products. And once you have done that, you need to eliminate any spectator ions. Once you have eliminated any spectator ions, you need to balance the equation, and you need to make sure that the charge is balanced. So let's write that down. Writing an ionic equation. 1. Write the molecular equation first. Use the information given in the question to determine the states for the reaction. Use solubility tables to determine the states for the products. Remove spectator ions if there are any. Balance the equation, make sure the charge is also balanced. Okay, that's what we are looking for here. Now, I'm going to bring up the solubility tables for the next part. So what we're going to have to do here, we are going to write the molecular equation first, and then we include the states. So the states for carbon dioxide obviously it's gas. It's given. Lithium hydroxide, we're told it's going to be in canister, and we're also told that there is water, which suggests that lithium hydroxide is aqueous, and lithium carbonate, if we go on the solubility table on carbonates, most carbonates are insoluble except sodium carbonate, potassium carbonate, and ammonium carbonate. So these are the only carbonates that are soluble, and lithium carbonate is not on there, so it's insoluble. So this one is going to be a solid. Water is a liquid because this is being conducted at normal standard room temperature. Okay, now once we have done this, where do we go from here? We need to write the molecular equation, and the molecular equation will look something like this: carbon dioxide gas plus lithium hydroxide, which is aqueous, which produces lithium carbonate, and water. I say this is solid, that's a liquid. Now, I look at this equation to see if I've got any spectator ions. Carbon is part of a gas, on here is part of a solid. Oxygen is now a solid from a gas, and some oxygen was aqueous. It went to a solid, some of it went to a liquid as well. So I can't eliminate anything, and more so, this is a gas, so we can only eliminate ions for aqueous reagents. Now, if we look at lithium hydroxide has lithium, which is aqueous, and it is gone on to be a solid there. The O and the H, some of the oxygen has gone on to be a solid, some of the oxygen has gone on to be a liquid. So I cannot eliminate anything. But there is lithium hydroxide. If an ionic substance is soluble, from what we did in year 11, it means this ionic substance is actually existing as in its as ions in solution, so it dissociates to its respective ions, rather should I say, to be more precise. So this must be written as separate ions to show how the way it is existing within that solution. So to finish off this one, the equation should look something like this: carbon dioxide gas plus lithium aqueous plus OH minus aqueous to produce lithium carbonate plus water, and we need to balance everything. And if we check our charge, we've got plus 2 here, minus 2. Plus 2 minus 2 is equal to 0. So the overall charge on the reactants is 0, and the overall charge on the products is also 0, because we only have neutral compounds on that side. So this is supposed to be your final answer. I'm going to finish off this one here, and I shall see you when you attempt the next question. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.